Okay. For the record, I'm doing this in front of 3 people, but they don't really want to be on camera. Okay, I have to start with drawing the cycle, basically. Kendall, can you see?
Yep.
Okay. This is your compressor. Wait, Caitlin, come here. You're missing this.
What?
You're gonna learn.
Are you recording?
Yeah.
Is this gonna be submitted?
Yeah. Because I really don't want to do another take.
Okay.
Caitlin.
I don't think it has the bottom half of your thing. Or am I tripping?
No, it does. You just can't really see. I'll get a zoomed in shot. Okay, you get to learn how the refrigeration cycle works. You're kind of in it. Okay. So, compressor goes to the condenser, which goes to the metering device, goes to the evaporator, back to the condenser, and I'll kind of like draw a little diagram inside, but pretend this whole thing's cut in half. This is the high pressure side, this is the low pressure side. So, hold on. Coils, air flows through these. And on this one, let me make sure I do this right. Yeah. Nope. I always get that one backwards. Okay, so as air is flowing through, it goes in warm and comes out hot on that side, keeps going through, cold on that side, and then it's warm. Are you guys actually learning?
Yeah.
Mm-hmm.
Yep, okay, cool. And then it switches pressure between here, and that's what that does. It's like a really small hole that switches pressure. So down here it's subcooled liquid. Over here it's flash gas, which if I remember right is 75% gas, 25% liquid. Or that's backwards, but people get confused on it, and it's confusing me right now. And then both of these, I'm gonna get 5 out of 5 points on this for sure. Superheated vapor on both sides, I'm not rewriting it. And that's the basics of how refrigeration works. And then of my 3 points I have to talk about, I chose how heat flows from hot to cold. And it's, because I wrote it down, it flows from hot to cold when there's a temperature difference, which is the principle of conservation of energy. Heat transfer occurs when there's a temperature difference, and warm molecules collide with the cold ones until it reaches a thermal equilibrium. And an example of that in real world is when y'all eat soup and the spoon is cold but the soup's hot and then the spoon warms up. That's heat transfer. You're not even paying attention.
I am.
Okay, second point is latent heat transfer. Okay. It's the energy absorbed or released during phase change, which phase change means like vaporization, freezing, condensation. And an example of that is sweating, because you're perspirating and then the sweat evaporates, and you sweat to regulate body temperature. So that's what that is.
Yeah.
Yeah. And then my last point is how compression raises temperature, and as temperature of gas increases, its volume also increases, and vice versa. The relationship between Charles' law of gas and gas compression can be clarified by considering the work done to the gas during compression. Work done on gas increases its kinetic energy, leading to an increase during compression. And the only example I have of that is literally just a compressor. You got to consider the work being done. Refrigeration, all this, all that. I don't think that made 5 minutes, but it's 11 o'clock and I'm not redoing this.